So, a fascinating aspect of sensation and perception is that in order to develop facility with perceptual abilities, in order to be able to, see, and actually consciously sort of see, feel, hear, etc., you actually need to have sensory experience, and that sensory experience, that engagement with stimuli in the world, actually has to occur during early periods of development for these sensory and perceptual systems to develop normally. So there are what we call critical periods of development for visual development, where you must be getting light input and actively sort of exploring your world visually, where you must get auditory input, because beyond that critical period, when that critical period closes, even if you now have access to light or access to sound, for example, you will not learn. You will not develop the networks to properly route the information from your eyes or ears into, cortical networks that are essential to support perceptual experiences. And there's really fascinating work that's been done recently as to why these critical periods exist. It turns out that before the end of the critical period, the neurons, where they meet, right, at these synaptic connections, right, they are actually quite free to move around and to form new, different connections, depending on the information that's coming into your eyes and ears. However, as that critical period starts to come to a close, there's this kind of extracellular, so it's outside the cells, but it's attached to the cells, this kind of scaffolding that starts to form that sort of limits what we call plasticity, the ability of neurons to kind of, change connections and form lots of new connections. The connections that have formed during these critical periods of visual development, for example, or auditory development, they become functionally organized and they're useful. So they get kind of scaffolded into place, right? And there's, this suggests actually for individuals who, actually have a cataract, for example, so they can't get light information during, this critical period of visual development in an infant. Well, if they can remove the cataracts, and let's say it's after the critical period is closed, and they're even though they're getting light, they're not going to properly develop the right connections, because these connections that were improper have been sort of scaffolded into place. Well, it turns out that in animal experiments, they've been able to inject compounds that can dissolve that scaffolding in the visual cortex. Remember, visual cortex is located in our occipital lobes towards the back, and it can actually restore plasticity. So now this light input, even though it's post-critical period, because you've dissolved those networks that were latching and holding, these connections in place, you can now sort of free up and increase plasticity and allow for development of networks that allow for the animal to actually perceive. This is pretty exciting. One of the things to think about is that as an infant, these networks are not quite formed, right? The visual information is not routing in the right direction yet. Auditory information is not properly routing in the right direction. And it turns out that there's a lot of overlap of these sensory kinds of networks in the infant brain. There's significant evidence to suggest that there's more of this kind of overlap, such that when they put an infant, for example, in an imaging scanner, and they show that infant a picture of its mother's face, you see areas in the occipital lobe and in the temporal lobe that are involved in the recognition of objects, right, that are like face recognition. You see those regions, get more blood flow. There's more activity, is what they call it, right? But you also see areas in the temporal lobe that are associated with auditory perception, and you see areas that are located in the insular lobe that are associated with gustatory or taste perception, and areas that are involved in the medial temporal lobe with olfactory perception, and areas that are involved in the somatosensory cortex, remember, in the parietal lobe for touch, etc., that are located, in somatosensory regions. So the infant is potentially having a much more multimodal, multi-sensory, multi-perceptual kind of experience. This is called synesthesia, which is that sort of mixing of senses. One kind of sensory input, in this case visual, provokes lots of other sensory associations, perceptual associations, actually, at the level of network distribution of this information. Well, when they test toddlers who are about 24 months, for example, you show them a picture of their mother, and it routes just primarily through the visual pathway. You don't see this sort of extensive activation. What we found is that there are many adults actually who retain some of these synesthetic experiences, so that they may see, let's say, the letter E, and every time they see that letter E, even if it's printed like in black text or something, it looks red to them, right? Or if they see a T, it looks green. So there's some kind of this is a common form of synesthesia actually, where the grapheme or the letter or number has an associated color with it. They call it grapheme color synesthesia. And synesthesia is actually relatively common in many of the classes that we teach, and many of the schools that we visit, for outreach activities. We often see students who actually have some form of synesthesia.